Welcome back to Geometry, Chapter 11, Section 3 in this book. We're talking about perimeters and areas of similar figures. And remember, similar figures are not congruent figures. Congruent figures have the same size and the same shape. Similar figures have the same shape but different sizes. And the symbol for similar is that little, kind of looks like a tilde in Spanish. I take Spanish in high school and college, 5 years of Spanish. Terrible at it. If you don't use it, you lose it. All right, just like math. If you don't use it, you lose it. All right, so to remember to get the perimeter of a figure like this, you do 2 times the length times 2 times the width. It's the how long it is to go all the way around it. To get the area is the length times width. And remember, by tradition, those are written in cursive. That's why you learn cursive, just for that moment. I think of it like with if you were redecorating a room. The carpet would be the area. It's like how much area is in the floor, how much carpet you would buy. The perimeter is the molding, the little wood stuff you put around the room to cover up the edge of the carpet. I'm sure that's why it's there, right? Because, I don't know. Anyway, I guess to cover whatever the floor is joined to the wall. Makes it look prettier. Alright, so let's talk about formulas for areas of certain figures. So I have 2 pentagons, and they're not regular, you can tell. And we already know the relationship. We can say the relationships of the sides. The side length of pentagon Roman numeral 1, we're going to call A, and the side length, this length down here, of pentagon 2, we're going to call B. And if we just wanted to look at those relationships of lengths, it would just be A to B. But if we're talking about area, where lengths are just linear, area is squared, it's multiplied. You know, like if you're buying lumber at Home Depot and you buy it just in the feet. But if you're buying something that has area to it, like a piece of plywood, then it's square feet, because it's feet times feet. So it's the same thing with comparing the areas of these 2 figures. If this is the relationship between length, the relationship between area, you square them. For example, this side is 5 and this side is 10. So if we were just looking at the relationship of these lengths, it would be 5 to 10, which is 1 to 2, or 1/2. But if we were going to look at the area of these 2, we could get it by squaring them. It would be 5 squared to 10 squared, 25 to 100, which is 1/4. So this area is 4 times bigger than that one. You can fit 4 of those if I had drawn it good. You can fit 4 of those in this one. So it like changes it exponentially, because there's exponents, when you move from length to area. It's not a one-on-one relationship anymore. And somebody told me that you have to take a math test to get hired at Home Depot and to get hired, I think, at Hobby Lobby, both. And someone said the big trick question on the Home Depot entrance exam is one about this, realizing that with area it's squared and length is not. So if you're trying to get on at Home Depot, there you go. There's your secret insider information. All right, so here's another kind of problem. This girl in the book is buying some photography paper, and for an 8 by 10 piece is 42 cents. She wants to know what's a reasonable rate for a 16 by 20. Notice these are twice as big. So the ratio is 1 to 2 from what she had to what she wants, but these are areas, so it's really 1 to 4, because you square them. And so 4 times 42 cents, she should pay about $1.68 a page. I don't know if that's a good price or not. I don't buy that very often. Sometimes photographic printer paper. All right, so here's an octagon, and they said that in the Chicago stock market that it's arranged in octagons. I wonder if it still is, because it used to be that people would yell and do pieces of paper to do the stock market, like a big auction. Yeah, you could go see videos of it. But now I think it's just all online. I think they just click on their computer. So I think there's no more yelling and throwing paper anymore. But I don't know. I'm not a stock market person. All right, so we've got octagons, a large one and a small one. The area of the large one is 980.4. The side of the large one is 14.25. The perimeter of the little one is 76. Well, we can get the side of the little one by dividing by 8, and we find out that the side of the little one is 9.5. Now we can set up a ratio. 9.5 is to 14.2 and reduce it to 2 is to 3. How I did that was on my calculator, I put 9.5 divided by 14.25, and then I went math, enter, and it'll give it to you as a fraction. And I think the math button is funny, because aren't they all math? All right, so if this is the relationship of the sides, the relationship of the area is that squared. And so this is the small area to the big, our unknown small area to the big. So we cross multiply, solve for x, and we get that x is 435.7. Is that reasonable? Yes. All right, I don't think this is too hard. I hope you enjoy it. Come back and we'll talk more about math. Math is great.